The Institute for Digital Entertainment Arts presents What is 3D? Chapter 1, Points and Space. Objectives for this video are, in this video, you'll be able to visualize 3D space, identify the position of a point in 3 dimensions, define a point, and describe the relationship between a point and space. So to begin, we're going to talk about a point in space. A point is nothing more than a position in space. A point itself has no volume. There's no mass. It is simply a location in space. The point itself has no sense of scale or proportion. It is not large, it's not small, it doesn't exist except as a data locator in a coordinate system or a speck of dust on your floor. The point exists with no reference to the space beyond itself. But for 3D animation and graphics and visual effects, we have to put a point somewhere. In fact, we have to put multiple points in multiple locations. Now we can arbitrarily decide that this point goes at 2, 4, 3. That's nice. But we're missing something. To say that a point is at 2, 4, 3 doesn't mean anything yet because we've not established a space for it to exist inside. The point needs a space, or these numbers make no sense and they become irrelevant. The space that I'm referring to in this video and the ones to come refers to a coordinate system. So when you hear people talk about your coordinate system, your axes, your x, y, z, this is what they mean by the space in which something exists. Consider it the bowl in which your soup goes. All right. The space, as I said, is a coordinate system, and furthermore, it provides the mapping so that these points in space can be plotted. This mapping, like the mapping of our planet Earth, let's go ahead and bring that up here. There we go, there's our Earth. This mapping, like the mapping of our Earth, has an origin from which to navigate. Origins are extraordinarily important. An origin tells you how far you are from a fixed location. In order to have multiple objects relate to each other inside of the same space, your space has to have an origin defined. The position of all objects are defined from this origin. The Earth itself does have an origin. It's an arbitrary origin, but it's one that humans have decided. And right on these main lines of longitude and latitude, right where the prime meridian and the equator cross, we have the origin for surface navigation on the planet Earth. And that origin is at 0 latitude and 0 longitude. But the Earth is a sphere, and we're not worried about polar coordinates. It's a very different topic for a much later time. What we are worried about, though, are 2 and 3 coordinate systems, not polar. If we take this Earth and we unwrap it, there we go. We can flatten this Earth out. We've now taken a polar coordinate system and reduced it to a 2D coordinate system. You'll often hear this called a Cartesian coordinate system, which is excellent. This shows that 2D space can have an origin. But what does this have to do with 3D? Of course, everything needs an origin. And this is an example that even the Earth needs an origin for people to navigate across it. For our next example, let's consider a piece of graph paper. Okay. There we go. Here's our graph paper. The graph paper is similar to what we had with the planet in that the coordinate system is flattened and it is two-dimensional. What we need to do though is right now the Earth, or at least this map of the Earth, has an origin, and we need to define an origin for our 2D system. So we'll hide the planet and let's create an origin for a 2D system. There we go. By defining this horizontal line as x and this vertical line as y, where these two lines cross creates the origin for your two-dimensional system. This point right here becomes the point 0, 0. Just as before, this point had a position of 2, 4, and 3. Our origin for this two-dimensional system is now 0, 0. Excellent. What we need to do though, we are working in 3D, so we're missing one dimension. And the last dimension we're missing is z, or depth. So x will be horizontal, y will be vertical, and z will be depth. Now if we take our piece of graph paper and extend out into the third dimension, this is what you'll get. We now have x, y, and z. We have 3 dimensions to define our 3 axes, and therein our coordinate space by which we can navigate and render all of our 3D objects. We can even rotate around our space. And as we rotate through our space, we can see that the origin, and this is important, the origin is not moving. The origin doesn't move. We are moving about the origin. It's a very important thing to keep in mind as you're beginning your journey in 3D. The origin doesn't move. Everything moves about the origin, just like we, the camera, are currently rotating about the origin. Great. Let's go back down to our flattened perspective. Here we are again at x and y. If we now draw a point, this point is at x2 and y1. So we can count our x's. Again, x is a horizontal line, so we can go 0, 1, 2, and for y, 0 and 1. So 1, 2, 1, that's our point. Now, as we pull out the third dimension again, this point will be at 2, 1, 3, so it will be 3 units deep. There we go, we can see it. So 1, 2x, 1, y, and 1, 2, 3 in z, or depth. So we can rotate around this. And we can see the point itself. We can see it from all sides. Again, the origin and the point are not moving. We are moving around the internal space. Always a fun little fact. This is but one point. One point by itself doesn't do much. Again, it has no volume. However, multiple points connected by edges and faces can create a mesh, and this is what a mesh looks like with multiple points. As I get close, you can see that some areas have very few points, and some areas are flooded with points. The more points you have in an area allows for more resolution and more detail in the model. This is one example of the millions of examples of what a 3D model looks like. And that is the mesh itself without showing vertices. This is what points in space do. Each point has its own location. The connection of each point to the next one and the next one to its neighbors defines edges. The connection of edges defines faces. And a collection of faces defines a model. This is how 3D begins, with points in space and in origin. This is the origin for this model, actually for the space in which this model sits. That about wraps it up for this video. Let's take care of some credits. The planet texture I used earlier is courtesy of planetpixelemporium.com/earth.html. And this video was made by Andrew Britton of the Institute for Digital Entertainment Arts.